Hi, I'm Steph.
And I'm Nicki.
And today we will be covering research done on the effect oxytocin has on alcohol consumption in prairie voles.
Primarily, we will take a look at oxytocin in the body and try to understand why introduction of the hormone may affect alcohol consumption in the first place. Oxytocin is sometimes known as the love hormone, and is made inside the hypothalamus and stored in the posterior pituitary gland awaiting release. From here, it can be used to stimulate contractions during childbirth, and it can also be used to stimulate milk letdown while nursing. Oxytocin has also been shown to play a role in social reward systems, emotional regulation, pain, and stress. It is these pathways which are our area of focus, as they may be the ones which affect alcohol consumption. It is suspected that increasing bond pairing caused by oxytocin may decrease substance reliance on alcohol, proving a connection between these two variables. Additionally, oxytocin has the ability to reduce ethanol-induced GABA receptor activity, which would cause less motor impairment in a subject overall while drinking. It is possible that without this motor impairment, alcohol becomes less appealing to its user, giving a basis for why alcohol consumption may decrease with a dosage of oxytocin.
People drink alcohol to socialize, celebrate, or relax. The effects of alcohol range from person to person, but depends on how much and how often one drinks, their age, health status, and family history. The main effect people feel is the effect alcohol has on their brain. Alcohol interferes with the brain's communication pathways and can affect one's mood, behavior, and coordination. Alcohol use, AUD, is a major public health concern with approximately 17 million adults suffering with the disorder.
Another interesting aspect of this experiment was the usage of prairie voles rather than rats. This was done because prairie voles are monogamous and mate for life after finding a partner. This gives the study extra depth in the way that it is able to test the effect of oxytocin with subjects similar to humans. This also makes the study more applicable to human alcohol addiction than a study regarding rats, which are not monogamous. This sort of pair bonding mindset can make a huge difference, as social implications of drinking have a large effect on alcohol consumption in both prairie voles and humans.
Now, getting into the procedure, 2 different alcohol distribution techniques were utilized in this experiment. The first was intermittent, in which alcohol was only provided to the prairie voles in half of the trial days. In this first set of trials, voles were placed in male and female pairs in cages separated by a mesh screen down the center. On half of the trial days, voles had access to one bottle containing 15% ethanol and another containing only water. Half the voles were then injected with either 1, 3, or 10 milligrams per kilogram of oxytocin depending on the trial day. The other half were injected with saline vehicles in order to serve as the control group. After this, alcohol and water consumption was measured after 1, 6, 12, and 24 hours. The second alcohol distribution technique used was continuous, in which voles had access to alcohol every single day of the experimentation. Once again, half of the days of experimentation only the saline was given, and in the other half, 3 milligrams per kilogram of oxytocin was given. Ethanol and water consumption were measured after 1, 6, 12, and 24 hours. Another trial was done additionally in which 1 vole per cage was treated with 10 milligrams of oxytocin, since that showed the most robust decrease of alcohol consumption, and the other vole was given the saline vehicle. Both were then given access to the alcohol and water, and their drinking was once again measured over the 1, 6, 12, and 24-hour intervals.
As visible in the graphs, it was found that overall, oxytocin did lessen alcohol consumption in the prairie voles versus when they were injected with only the saline vehicle. However, the effects were much more prominent when measured over a 1-hour basis. On a 24-hour scale, the alcohol consumption of the voles was rather similar regardless of injection of oxytocin or the vehicle. As can be seen in this graph, the difference made by the oxytocin started out rather high, but began to dwindle after the 6-hour mark. Although, males in the intermittent access group saw a greater difference after the 6-hour mark, making oxytocin's effect much longer lasting for this group. It can also be noted that voles with intermittent access drank much more when they were given the chance in comparison to voles with continuous access to alcohol. Finally, it can be seen that in the intermittent trial, the biggest difference in alcohol consumption was made at the highest dosage of oxytocin at 10 milligrams per kilogram.
Oxytocin works to reduce voluntary alcohol consumption in prairie voles. The effects oxytocin had on the prairie voles' consumption of alcohol, however, didn't last long and showed most effective in the first hour of alcohol access. Oxytocin reduced alcohol consumption by about 40% in the first hour, but only reduced 24-hour consumption by a small amount. 10 milligrams of oxytocin actually showed a more significant reduction in alcohol consumption in males over the 24-hour period, but they still drank a relatively high amount of alcohol. While alcohol consumption decreased, that was not due to the lack of fluids prairie voles drank. The role of social facilitation in alcohol consumption was seen in some, but not in all pairs of prairie voles. Alcohol consumption by one vole predicts consumption by the other in the cage, but water consumption was not matched. That showed that this behavior was alcohol specific. What this experiment fails to show is when one cage mate is injected with oxytocin, the other should match the alcohol consumption. There were significant variables across cages, with some cages showing matched consumption by cage mates, and some showing no relationship between the consumption by cage mates, and some showing inverse relationships of consumption with cage mates. This experiment helps to broaden the understanding we have on the effects oxytocin has on alcohol consumption.
Although this study used very respectable methods of acquiring data, no experiment is perfect, and a couple things could have been improved. Primarily, an increase in sample size can always increase the validity of an experiment. In this study, there are 34 male and 34 female prairie voles used, which is not an outrageously low number, but the more data collected, the more rigid conclusions can be drawn. The voles used also would have benefited from random selection, as all were bred and housed in the same facility before the study took place. Had random mated vole pairs been selected from random breeding centers, the study would have added an extra layer of randomization to ensure the least amount of bias possible. Aside from these small changes, though, the study was very well constructed in terms of ensuring proper data collection.
Future experiments should investigate a wider range of oxytocin dosages to detect the threshold of oxytocin's effect on alcohol drinking in prairie voles. Future studies should also further investigate the important social aspects of prairie vole drinking relationship when one is given oxytocin and the other isn't. Overall, future research will also need to investigate the mechanism of oxytocin's effect on alcohol drinking. The data from this experiment adds more supporting information for the potential of oxytocin as AUD treatments.
And that concludes our presentation. Thanks for watching. Bye!